You can go back and look at this. All right, so we did the front on this yesterday. Going to the back. What is different? Look at your front. Look at my back right here. Look at yours on the front, and then look at mine on the back. What's different? There is no triangle. So the difference here is they did not give you the picture to start with. Instead, they're saying, hey, I'm going to give you tan of theta. It's 7 over 24. I need you to find the remaining 6. Well, technically remaining 5. So like tan of theta is 7 over 24. I already know it. It's right here, right? 7 over 24. How do you get the rest of them? You're going to have to draw a picture, label, find that third side, and then finish. Okay? So let's make a note. You're going to have to, 1, draw a pic. Then you're going to need to label all of the information that you know. You will need to find the missing side. And then you can finish the problem. So there's a little bit of extra steps involved. So I tend to always draw my right triangles like this. Don't know why, it's a habit. If I ever draw the triangle like this though, what kind of triangle is this one? Yeah, it's a left triangle. Right. No, you're right. This is a right triangle. This is also a right triangle. It's because it has the right angle in it. Just because it's opening to the left doesn't make it a left triangle. Now, you might be thinking, how in the world... Okay, so now we're going to label the triangle, and you might be thinking, how do you know what to put where? You get one free choice. So yours may vary from your neighbor. That is where you put theta. Theta can vary from person to person. Because remember, we don't know what theta is. So it really doesn't matter where you put it. It's just an unknown angle. Usually, I tend to put theta down here when I'm drawing the triangle. Don't know why. But it really doesn't matter. Now, where you put theta will now dictate where some of the other numbers go. Okay, so remember, this is my hypotenuse, this is my theta, which means this over here is my opposite, and this is my adjacent. How do I know what numbers to put where? You have to look at this and remember the formula for tangent. The tangent formula is opposite over adjacent. So they are telling you by that equation, hey, opposite of theta is 7 and adjacent to theta is 24. So we're going to fill it in. We got opposite 7, adjacent 24. Now I know I've got to find that hypotenuse using Pythagorean theorem. So that's going to be 7 squared plus 24 squared equals c squared. What'd you get for C?
It's 25. It comes out to 625, but that is the square root.
That's a perfect square?
Yeah.
Okay. If we come to, we've not had one yet come to an imperfect square, but if you come to one that's imperfect, you don't want to do a decimal unless the directions tell you to. You want to leave it as a radical. Sometimes you want to break it down if it can. Sometimes they don't break down. I feel like we don't necessarily have to finish these. You can finish them and I can check them if you want. But I want to kind of cover all the possible scenarios. So now, like coming over here to this one, you would start this the same way by recognizing, okay, they didn't give me a picture, but they did give me one trig ratio. Cosecant if you think back to what we talked about yesterday, starts with a C. This is the reciprocal function, and it starts with a C. So that means that I need the sine function formula, and then I just flip it to get the cosecant. So sine is opposite over hypotenuse. So this would be hypotenuse over opposite. And then fill in your picture, find your missing side. Let's see, this one probably does not come to a pretty number, so let's try that part. I'm going to put theta here. I've got to zoom in. My contact lens prescription is off. This is 37. Okay, I'm good at math, but I can't do this. 37 squared minus 12 squared. What's that? What'd you get? Oh man, I was hoping for something ugly. Did y'all get 35 as the...
Yep.
Okay, well. So then you would finish the 6. Let's see. 81 minus 25. 61. 55. Let's look at 7. I don't think 7 ends up being pretty. So this is cosine. That's adjacent over hypotenuse. So adjacent is 5. Hypotenuse is 9. Find that missing leg. You get a squared equals 55. Did you get 55 when you subtracted? 8 or 50? Oh, 56. Here we go. Nope, this one's not pretty. So a is the square root of 56. You want to leave it like that. You don't want the decimal. Let's see, factors of 56. 1, 56. 2, 30 or 28. Yeah, 3 won't go. 4 doesn't go, right? Yes, 4 goes in 14 times. 5 won't go. 6, 7 times 8. It's looped back around. So we're done. Any of these perfect? 4. Do y'all remember perfect squares? Vaguely? Yes? No? Perfect squares. This is so cool. I'm derailing for a second. If you had a square, and yes, I know that's a circle, but please pretend it's a square. If you had a square that measured 1 by 1, what would the area of it be? 1. Okay, thank you. 1. If you had a square that measured 2 by 2, what would the area of it be? 4. If you had a square that measured 3 by 3, what would the area be? 9. Oh, that was way too much. 9. If you're wondering how they got this, they're multiplying the dimensions together because that's the area formula, length times width. If you had a square that was a area of, or dimensions 4 by 4, this is way off. What would the area be? 16. Do you notice these numbers that I'm coming up with every time we find the area? Do you notice that they're all the perfect squares? That's because they're literally built from a square. That's where the idea of perfect squares came from. It's the numbers that when you find the area of squares, it's the number you get for the area. So you got 1, 4, 9, 16. Next would be a 5 by 5, which has an area of 25. Okay, so these are called perfect squares. The square root of these perfect squares comes back to just the row or the column. So the square root of 4 is 2. Okay, so this is a crash course. We need to break down root 56. Root 56, 56, factor tree it down. You want the first number to be the perfect square and then whatever's left over. So we said 4 goes into it. How many times? 14. This one needs to be your perfect square because this one's going to keep going. The square root of 4 is 2. This comes down. So instead of writing the square root of 56 over here, you need to write 2 root 14. 2, trying to write sideways on this tablet, and it's awful. There we go. 2 root 14. So now when I go to find this, for the most part, it's already simplified. You're just going to have to rationalize with the root 14. Okay? So let's find one that's ugly. Tangent would put the radical in the top. So let's do the opposite of tangent. Let's do cotan. So cotan would be the opposite of tangent. That means opposite over adjacent flipped. So adjacent is 5 and opposite is 2 root 14. So I would need to multiply by root 14 over root 14 to clean this up. On top, it's just going to shove together. I got 5 root 14. On bottom, you'd end up with 2 times 14, which is 28. And that one would be done. I don't think I said it yesterday. So this math class, a lot of people get nervous about pre-cal. And it really does matter who's teaching it. That's not trying to sound cocky. It's some teachers teach it like way up here because they can't see. I guess they can't see like where you might be confused because maybe they never struggled when they learned it themselves. I struggled in middle school with math, and then I ended up getting a tutor, and then it clicked, and then I started loving it. So I can see where people get confused because I was there one day. So what I want you to understand is, if I present it to this way to you, maybe it's not as intimidating. What we're going to learn is stuff that you have already learned at some point. It's just we're going to have ugly numbers. Like, you know, when you learned this in geometry, you rarely came to numbers like this. So we're going to have ugly answers. We're going to have, like when the problem starts, it may not be just given to you in a picture. It may be given to you like this, and you have to draw the picture. You see what I mean? But all the skills are still the same. So, yes, pre-cal is challenging, but it's completely doable when you understand I'm still using the same skills I've always learned. It's just now I have ugly answers. Okay? So keep that in mind. And then what if they give you the, ratio, but it's a whole number? Don't forget every number's over 1. So that's 4 over 1. So that's where your second number comes in. Of course, this is secant, that starts with an S. That's the opposite of cosine. Cosine's adjacent over hypotenuse. So this would be the hypotenuse over the adjacent. And I think that might be it for this paper. This down here is a great chart. We're going to actually fill this in next week with the actual answers. I don't want to work it out yet. I want to skip to this sheet right here. What time is it? 3 o'clock. He still has not sent that text.
They just issued a official, let me read it. My mom just sent it to me. It is official. U.S. National Weather Service has issued a winter storm warning for Ringgold. It will be effective until January 11th, 7 a.m. Eastern Standard Time.
We're what was it? First and foremost, and if you have a highlighter, you may want to highlight this. Since we are fixing to start typing the buttons on your calculator that actually say sine, cosine, tangent, you need to make sure your calculator is in degree mode. There are two measures for angles. There's degrees and then there's radians. Did y'all learn radians in geometry? Okay, not a problem. We're going to get into radians. Radians is more calculus, pre-cal and calculus. Right now we're going to just see, do you remember how to do it in degrees? Because we also have degrees throughout the semester. So what you're going to do is hit mode on your calculator and then just arrow down and hit enter over the word degree. You want to be in degree mode. Then once you are, just hit clear and come out of it. All right, so this whole paper is showing you how to use trig to solve for a missing side or a missing angle. Sides and angles. So this is, all right, let's jump around. Let's go to number 7. Okay, so look at this picture. Notice we don't have a theta. This time we actually know the angle is 39. Okay, so draw your arc and then draw your arrow to the hypotenuse as well. Now, we don't need all 3 sides labeled here. We are actually, the goal is, it says find the value of x, round to the nearest tenth. This is our goal. We're going to label the 2 sides that we do have. Okay, so 11 is really far away, so that's opposite. X is right next to it, so that's adjacent. Let's write our trig functions over here. Sine, opposite over adjacent. Cosine, I said opposite over adjacent, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. Once you label the 2 sides that they are giving you, ask yourself, which trig function am I using here? I've got opposite and adjacent, so I'm using which one? Look at my fractions. Look for O and A. Yeah, I'm using tangent. So the biggest question people say is, how do you know which trig function to use? That's how. You label your picture. Don't label all 3 sides though, because then you might confuse yourself. You're labeling just the 2 sides that they give you, and then ask yourself which formula over here works. Tangent works. All right. Then you're going to set it up. It's going to be trig function, angle measure, equals fraction bar. Then it's going to be a number over a number. Trig function, angle measure, equals fraction bar, and then it's going to be a number over a number. These numbers, by the way, because it comes from these formulas, these are always sides, side measures. Your fraction should always be side measures. And then this number should always be an angle. All right, here we go. So we're going to set it up. Tangent of 39 degrees equals fraction bar, opposite over adjacent. So 11 over x. Okay, we're solving. We need to get x by itself. The first thing you're going to do is to cross multiply. Do you notice how this is understood to be over 1 and then I have a fraction equals a fraction? Okay, so when you're solving fractions, you cross multiply. So technically, we're going to cross multiply here. Do you want a tissue, sweetie? Because it's way softer than those. Just help yourself. Come here. Come over here. And then slide my chair. I keep them over here so people don't use them to clean up spills. Okay, so what I was saying is this is a fraction equals a fraction. You can cross multiply to solve. We don't really need to multiply the 1 to the 11 because nothing changes. What you're really going to do is you're going to multiply whatever's in the bottom of this fraction all the way over here. I want you to start practicing drawing what's called an elbow arrow. I call it an elbow arrow. You know when, you may not know, if your turn signals don't work on your car, you're supposed to use your arm out the window, you know, and it's either like up or it's out, like I'm turning, you know what I mean? So this is almost like a turn signal. I call it an elbow arrow. What you're doing is you're giving yourself the visual cue. I'm going to multiply this because the opposite of division is multiplication. I'm going to multiply this over here to the front. Now, I could write it right here, but I'm just going to come down here and write it again. So that gives me x tan 39 degrees equals 11. Now, x is almost by itself in the right place. The only thing in the way is tan 39. If you will show your work, you won't have to write as much because I can see, okay, it's attached here by multiplication, so the opposite would be division, tan 39. Now, whatever you do to one side, you got to do to the other. And now I can see exactly what to type in the calculator. You're going to type 11 divided by tan 39. And now you're going to get a decimal. Welcome to decimals. We are going to have a lot of decimals throughout the course. They do want you to go to the nearest tenth. So what is it? Because I don't know.
13.58.
Okay. So if it's 5/8, the 8 definitely bumps the 5 to a 6. So that missing side's 13.6, which is right here. So what you just did was you used trig to solve for a missing side of a right triangle. And you might think, well, why couldn't I have done the Pythagorean theorem? Can anybody tell me looking at that picture?
You don't.
Right. Why not? There you go. Pythagorean theorem requires you to have only one missing side. We actually have two missing sides here. We don't know the hypotenuse either. So you can't do Pythagorean theorem, which is why trig is so nice, because as long as I have a side and an angle, I can find everything on that triangle. Now, we're not finding all 6 trig ratios either. That was it. That's all that is on that problem. There is one more possible scenario. The x could be in a different spot. So this one's going to do it. Let's do this one. Draw an arrow to the hypotenuse. There's something there, so I'm going to label it with H. I'm going to draw my arc on the 46. X is positioned how to the 46? It's adjacent. So then go over there to your trig functions and say, okay, which one's adjacent and hypotenuse? Which trig function uses adjacent and hypotenuse?
Oh, cosine.
Cosine. All right, so set it up. Cosine, angle measure, equals fraction bar. Fill it in. We got x over 28. I need to zoom in again. I don't think my contact prescription is correct because it's like hurting my eyes. Okay, notice the difference. What's the difference? By the way, that's a mathematical practice, like being able to compare two things and decide that something's different or something's the same. What's different? Yeah, the x is now in the top. It just means you have a shorter problem. You still start it the same way. Just think of it this way. When your car needs to turn and your blinker's broken, you've got to stick your arm out the window before you decide if you're turning right or left. So we're going to draw our elbow arrow. It really helps give that visual of, okay, this denominator is coming over to the front. So I'm going to write what I get. I get 28 cosine 46. And as ugly as this is, look what's now by itself. Which is why this is short and sweet. Well, that's not it is the answer, but it's in the wrong form. You got to type it in the calculator. Get it in decimal form. All right, here's a checkpoint. What if you typed it in, I don't know, I'm just coming up with something. And let's say you got 32. You got, this is 32. Is that possible?
No.
Why?
Because the hypotenuse has to be the biggest.
There you go. Along the way, as we learn stuff, always look back and ask yourself, is my answer possible? So, like with triangles, you know, if they tell you the hypotenuse, then you have some context of, okay, the biggest side's 28. So my answer over here better not be higher than 28. So keep that in the back of your mind. Now, the good news is this is scenario 1 and this is scenario 2 when you're solving for a missing side. Okay? So coming down here to these, like if you were to work them out, there's no third scenario. X is either going to be in the bottom or X is going to be in the top. If it's in the bottom, it has that additional little step. If it's in the top, it's short, sweet, to the point, and a lot faster. Okay? That's enough. That's good.